What up, guys? Today we're going to look at dilations. And so dilation is the enlargement or reduction of a figure, right? The scale factor tells us how much we're going to enlarge or reduce a figure, right? And the variable that we use for a scale factor is k. And so when k is less than 1, the dilation, or sorry, if k is greater than 1, the dilation is an enlargement. When k is less than 1, the dilation is a reduction. Right, so you have to pay attention to what k is. Usually if it's less than 1, they give it to us as a fraction. All right, so let's look at some examples. So here's number 1. All right, we're going to graph and label the figure and its image, right, under the dilation. And so here's my pre-image already graphed. They want us to dilate it 2. And so with the graphing, that's easy because we always start at the origin. So you're going to count from the origin, right? And then you're just going to count left, right, up, down, and we're going to do it twice. And so notice, to get to T, we have to go right 2, down 1. So we're going to go right 2, down 1, 2 times, starting from the origin. So right 2, down 1, that's 1. Right 2, down 1, that's 2. And so T prime is at that point. To get to S, notice we're going to go up 1, 2, 3, 4, and then left 1, 2, 3. So up 4, left 3. So up 4, left 3, that's 1. 1, 2, 3, 4, up 4. 1, 2, 3, left 3, that's 2, and there is S. And then for R, we're going 1, 2, 3, 4, 5, and then 1, right? 5 left, up 1, 1, 2, 3, 4, 5, up 1, and that would be R prime, right? So if you notice, to the point, when I count to the point, that's always 1, and then counting one more time gives me 2. If I count again, that would be 3, and then 4, and then 5, and so on, right? And so there is R prime, S prime, T prime. So there's our new triangle, right? And then we just need to write in the points. And so T prime is at 2, 4. So T prime is at 4, negative 2. S is at 1, 2, 3, negative 6, 4, 5, 6, 7, 8. So S is negative 6, 8. And then R, 5, negative 10, 2. Right, so you can count. The other method would be to just multiply, and we'll look at that here next. And so in our next example, here they want us to dilate it by a scale factor of 3. And so we are going to multiply every single point by 3. And so here if we look at A, negative 3 times 3 is negative 9. 0 times 3 is still 0. 1 times 3 is 1. 2 times 3 is 6. And then we have 2 times 3 again, which is 6. 0 times 3 gives me 0. And then for point D, negative 2 times 3 is negative 6. So they'll both be negative 6. All right, so this is the other method. So now if we plot these points, so negative 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is A prime. B is at 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. There's B prime. C is 6, 0. 1, 2, 3, 4, 5, 6. C prime, and then D is at negative 6, 6. So 1, 2, 3, 4, 5, 6. And then negative 6. 1, 2, 3, 4, 5, 6. And there is D prime. Right? The method I used for number 1 still applies. Right? So if I start at the origin and I count, all right, so let's go to B. So I go up to right 1. So that's 1. That's 1 time. Up to right 1 is 2 times. Up to right 1 is 3 times. So notice that that method still applies. Right? You can do the same thing for A because we just go 1, 2, 3 to the right. So that's once, or left, sorry. So that's once. 1, 2, 3 is 2. 1, 2, 3, that's 3. Right? And we wanted to multiply by 3. And so notice that same method works. So now if you go back and we look at the answers from number 1, the multiplication method works for this one as well because we wanted to multiply by 2. So negative 5 times 2 is 10. 1 times 2 is 2. Right? And so on and so forth. And so both of those methods work. Whichever one works best for you is the one I would use. All right, so that's if we have an enlargement, because notice that the scale factors were both greater than 1. All right, but what happens if the scale factor is less than 1? So now if we look at number 3, right, I'm going to use the mathematical method. So I'm not going to count or anything. I'm just going to use the math method. So here, what's happening is, so we want to multiply this by 1/2, and so we would get 10 times 1/2. Well, 10 is a fraction, and so if I multiply this, I would get 10 over 2. But if I simplify this, right, 10 divided by 2 is 5. Oops, and those should be negative. So negative, negative, oops, not that one. Right. So negative 10, and then that's a negative 5. Right, and so I know that J prime, that first value is negative 5. Here, I have 2. So I would use the same method, right? And so I would have 2 times, or 2 over 1 times 1/2, which is equal to 2 over 2. 2 over 2 reduces to 1. And so I know that J prime, the Y value, is now 1. And so if you look, it was negative 10, now it's negative 5. The Y value was 2, now it's 1. Right? What do you see? Hopefully you see that negative 10, when I divide it in half, is negative 5. 2, right? When I divide it in half, or divide by 2, I get 1. And so even though this thing is a fraction, all it's telling me to do is to divide by 2, because it's 1/2, right? It just wants half of that value. And so K prime is going to be at negative 1, 4, right? Because just half of those values. So L prime, I'm going to take half of 6 and half of 2, right? Half of 6 is 3, half of 2 is 1. And then for M prime, half of negative 2 is negative 1, and half of negative 4 is negative 2. Right? And then we could plot those points, and you would see that the distance from the origin to the pre-image, and then from the origin to the image, is half the distance. So you would only count half. So for example, right, if we look at L prime is at 3, 1, so 3, 1. Here is L prime, right? So to the pre-image, it's 1, 2, 3, 4, 5, 6, up 2, right? Half of 6 is 3, half of 2 is 1. And again, if you count, it'd be up 1, right? up 1, over 3, up 1, over 3. Notice we went 1, 2 times. And so then half of that, right, that would be half of the original distance, and so it gives me that 1 point there. And so doing the math is much faster, and then you can plot all the points a little bit faster as well. And so if we look at number 4, right, again, I'm just going to do the math. And if you look, this time it's 1 over 4, or it's telling us to just divide by 4. So we're going to take each number and divide it by 4. And so negative 4 divided by 4 is a negative 1. 8 divided by 4 is 2. This one here is tricky because it's 10 divided by 4. And so if we look, 10 divided by 4 is this fraction, right? We can reduce this. So if we divide by 2, we would get 5 over 2, right? If we completely divide this, 5 divided by 2 is 2.5, 2.5. And so x would be at 2.5. 0 divided by 4 is still 0. This one, again, also tricky because now we have a negative 2 divided by 4. If we reduce this, we will get negative 1 over 2. Negative 1 over 2 is the same as negative 0.5 because it's just half. And so we would get negative 0.5. And then the last one, negative 8 divided by 4 is negative 2. So then you'd go and you'd be able to plot all those points, right? So negative 1, 2, there's W prime, 2.5, 0, 2.5, right? There's X prime, and then Y prime is at negative half, negative 2, which is right there, and that's Y prime. And so there is our image of the triangle. And so notice, because this was less than 1, it's a reduction, and so the image should be smaller. All right? So do the math. It makes things faster, right? It does get a little bit harder. You could always bust out your calculator if you need to. If you have any questions, again, leave a comment, email me, direct message me, ask me tomorrow at school, whatever you need to do so we can get you on the right track. All right? Have fun with the homework. See ya.